Okay, so in the labs, you've already done a little bit of HTML. I'm going to do some more this week. I just want to talk you through some basics that we didn't really discuss before. Obviously, by now you know my name and you know my offices. But I want to just talk a little bit about the internet. I mean, some of it's going to sound a bit silly, like, you know, as if you haven't heard of the internet. Obviously, you have. But I just want you to get a feel for how it works conceptually when you look at a web page, just because that has some consequences for the way HTML works. But even by the end of this semester, you'll actually know more about networks than I do. So it's just kind of very vague and conceptual. So networks obviously allow computers to talk to each other, and they can have different topologies, we call them, different configurations. And the way they're set up then can have consequences in the event of a failure. So if you have something like this topology here, where they're all lined up in a row, and then one of the machine fails, well, then that connection between those two at the end and the rest of the network is broken. And then they can still talk to each other, but they're disconnected from the rest of the network. And so depending on how you set up your network, it can be more or less tolerant of failure. So during the Cold War, the US military gave money to colleges to try and devise networks that could survive a nuclear attack. It's, I suppose, not as hard to imagine as it might be, but anyway, at one stage there was, a real fear that there would be a nuclear war and that many cities would be destroyed. And obviously you wanted to keep going as best you could. The cities that were destroyed would be gone, but you would like the rest of the network to keep going. So you can imagine a network with a center. Let's say you had all the data coming into the central point and heading out again. A network with a center like that would be easy to take out if that center was destroyed. And so the objective was a network that would be able to survive an attack. And so a network with multiple routes between points would be able to survive such an attack. So when you send something from A to B, it has many different possible ways to go. And if one of those ways is gone, it just finds another way. So there isn't necessarily a direct path from, say, New York to San Francisco. A piece of information only knows that it's trying to get to San Francisco. And then the way it gets there can be routed dynamically and change and alter depending on circumstances. The original intent was, the changing circumstances would be the, annihilation of Los Angeles or something. But nowadays, that changing circumstances can be things like, busy traffic or a power failure or a server being down, whatever. One of the consequences of the internet not having a center and having it being distributed, of course, that it's very hard to control. If it has no boss, if it has no center, then if you don't like something, how do you shut it down? And we've seen that in the example of, say, piracy. If you want to shut something down, it's very hard. You can just move it. If you block something, there are ways around it. People have. You take, say, the government of China doesn't want certain things coming in and out. It can be hard sometimes to block everything. There are ways around things. Stuff like that. So many of the features of the internet that we see today are hardwired in there. And many attempts to control the internet have been unsuccessful because of that. Now, obviously, if you are an island and you've only got one pipe, data coming into the country, well, you can sit on that and control what comes and goes. And in some countries, everything comes through one point. so that it can be controlled. So we have a decentralized network that no one owns. Now, it's important to distinguish between the internet and the World Wide Web. Many of you are so young that you have never known the internet without the World Wide Web. But when I was in college, there was the internet, there was just no web. So the internet is the infrastructure, it's the backbone, it's the wires and the protocols, well, the wires and the stuff that the information travels on. On top of that, then you have different protocols. So you have email, for example. So email has been around for a very long time. There's a thing called file transfer protocol, which allows you to transfer files from one place to another. Telnet, you don't see that much anymore, but it allows you to log into a computer from a remote location. So a whole bunch of different protocols. And there will be new ones when new people come up with new things. I mean, chat services use different protocols as well, things like that. So the World Wide Web was just one thing on the internet. It's just one protocol, and it uses hypertext transfer protocol. And this was developed at CERN. I think they had their 25th anniversary there recently, not of CERN, but of the world's first web server. It's 20th or 25th, I'm not sure. And CERN is this place where they speed up subatomic particles really, really fast and smash them into each other and see what happens. And based on the debris, you can find out about the nature of the universe and stuff. There was a guy there who worked on a project to try and make it easier to disseminate the research findings. So in the past, back in the day, let's say I published a really interesting paper or I had some interesting research results. Before the web, I would put those on an FTP server, file transfer protocol server. And someone would log in to my server, and there might be a file that has a list of all of the documents and what they're about, maybe summaries, and they say, oh yeah, okay, I think I get that one and that one and that one. So then they would log in and do an FTP and copy the file down, and then they'd have a copy of it, and then they could print it. The hypertext transfer protocol was a way to maybe make that process a bit better. So we have hypertext markup language, or HTML, and we use that to describe the content of web pages. Crucially, a part of that was the links between pages, and that became very, very important. Now, so there are stages when you go to look at something on your web. When you go to look at a web page. So I'm sitting there in the browser. Sometimes if you're trying to explain to a person who's not very computer savvy, they think like the browser is the internet, and somehow that all that knowledge is in there in the browser. But of course, a browser is just a program that displays web pages and goes and gets them for you. The computer doesn't have all that knowledge inside in it. That's what it seems like to a child, that the computer knows all these things. The computer is just a window on the world out there. It's just a kind of a dumb terminal almost. So in your browser, you might have a link. But different kinds of browsers, obviously. Internet Explorer was once the most popular and most widely used. Now it's just widely used but not popular. And Opera was popular because Opera was designed to sort of be very, very fast and optimized, and so if you're using Opera and web servers set up to work well with Opera, things can download much faster. Some countries, Opera is like just the thing that everyone uses. Apple developed its own browser that's called Safari. Then you've Firefox, and you've got Chrome as well. The reason actually there's so many browsers, when you consider that they all do the same thing, is that the browser is your interface to the web. And it's a bit like there were problems in the early days. Microsoft had a tendency to abuse the fact that everyone's using Internet Explorer. It used that leverage that there were so many people using Internet Explorer to help other parts of the business. And you can see how if you're using Chrome, that's a benefit to Google. It's a little bit like if you imagine Sky TV also made televisions. And then every time you turned on your TV, the first channel that came on was Sky News. And okay, you could probably go in and find the settings and stuff and change it so that, the first channel that came on when you turned on your TV was CNN. But would you bother? And similarly, so anyway, that's why all these companies have gotten involved in the browser business. Apple was concerned, for example, that if it didn't have its own browser, it would lose out on things. But we won't get into the politics of all that. Anyway, so you have your browser, whichever one you're using. People have their own preferences and stuff. As nerds, you'll be expected to use Chrome or Firefox. Unless you're a Mac person, you'll have Safari. You can get Safari for Windows as well, but you don't see that very often. In the early days too, they didn't conform to the standards as well as they should. So people who were interested in standards would have been more concerned with one or the other. But now they're all pretty much behaving now. So everything's fine. Anyway, so you have a link on your web page that you see in the browser, and you click on that link, and away you go. So you could type it in, for example. You could say www.cit.ie. I don't see people typing anymore. You can go up to the address bar of a browser and you can say www.cit.ie and go straight there. You can go www.rte.ie and go straight there. In my experience, I only ever see people Googling RTE or Googling CIT. I've even seen people Google. So it's just an age thing, I think. Someone my age, if they want to go to the RTE website, will go up to the address bar and go www.rte.ie. It wouldn't occur to us to go to Google and Google RTE and then click on the link. But that's just a thing. Now, so this URL then is a request to a server to give you a file. So that goes out onto the internet and finds its way somehow to the server that has that file. So that server might be sitting in Florida or something. Web servers then are computers that sit there all day, and their job is to take requests for files from people, get the file they want, and give it to them. So the URL will determine who wants what. And so it goes away then and gives them that file. You could set up a web server in your house, but you probably wouldn't bother because you can get someone to do it for you really cheap anyway. So that web server just sits there all day giving out files to people. So that file that you requested will work its way then back across the internet somehow and come back to your browser. And it comes back to your browser as a HTML document, a HTML file. So the browser then will look at the HTML and will start to lay out the page. It says, okay, there's a thing up here, there's a thing up here, and blah, blah, blah. Now, HTML files don't contain actual images, they just contain links to images. So if there are images in the web page, as happens very, very often, well then the browser has to go off and get those images. So it goes off and sends a request to the web server again, or maybe even a different web server, depending where the image is coming from, for the image file, and that image file works its way back to the browser and displays again. Often this happens instantly. In the early days of the internet, it didn't happen instantly at all. You would see the page and then dum, dee dum, dee dum, dee dum, dee dum. The images would slowly, download, and you'd see the image. But it's important to realize that the image is not in the HTML file. It's a separate file again that has to go off and come back again. And when you're designing a website, You need to understand that conceptually, even if in reality it practically happens instantly. You don't see the difference. No, I mean when you're out and about on your mobile phone, up a mountain in the Culture counties, like you won't have images downloading instantly. So in the mobile sphere, we still are aware of the fact that these things don't happen instantly and that images will take a while. But when you're sitting at home with your broadband, you don't notice. Now, the browser lays out then the web page that's as it's specified by the HTML. And different browsers might make it look slightly differently. Some people get obsessed with the fact that the different browsers display the pages differently. And so they may be doing things like, now if it's Internet Explorer, we're going to do this and this and this, and then if it's this browser, we'll do this. And like, you just have to get over it. You don't have total control over how it's going to look. You specify as best you can the structure of the document and the layout of it, and then you let the browser do its thing. And you don't get too hung up if the browser doesn't do your bidding exactly. Well, get over it. You can go mad, worrying about there's a pixel out here and, this isn't exactly the way I wanted it. Your job is to make well-constructed, syntactically valid, well-designed HTML pages and let the browser do its thing. Okay. Sometimes we have what's called a broken link. That's if you mistype the URL or if it isn't spelled properly. So if you have, www.cit.tie or something, there's no such thing. So that wouldn't work. Sometimes or if you request a file from a web server and it's not there, it just comes back with an error. So we've seen that HTML files are in bog standard plain text. You can call your HTML files .htm files or .html files. It doesn't really matter what you do, but you should pick one and stick with it, otherwise you could have cause confusion. You are going to use .html, okay? You're card-carrying nerds now, and we do .html, okay? The cool people use .html, right? And images on web pages can either be a GIF, a JPEG, or a PNG. In this module, we probably look a lot at the differences between those images just because it's something I like to talk about and it is relevant. We have GIF, which is Graphics Interchange Format, JPEG, Joint Photographic Experts Group, and then PNG, Portable Network Graphics. PNG files are typically very big. JPEG is great for photographs and things like that. GIF is usually better for graphics, logos, buttons, stuff like that. There's some dispute in the nerd community as to whether it's GIF or GIF. The GIF people are right, but they're still Muppets. So we're just going to call, and GIF is more common in Ireland, okay? The GIFs did win, okay? I mean, they are right, because the person who devised it said, no, it's GIF, but like, whatever, GIF, okay? So in Ireland, it's mostly GIF. And if, you'd be in a bar some night and there'll be a big fight in San Francisco or something, and it'll just be about, whether it was GIF or GIF. Now, hypertext markup language, HTML. We've seen some of this in the labs already, so I won't go into that. We saw this already. We've seen links already. Paths are important. So when you're specifying a link, be it for another page or for an image, you must specify the exact URL where the file is found. However, if you don't specify the full path, if you just specify a partial path, so if you just say the name of the file, the web browser will assume that the location of the file that you're looking for is the same place as the HTML file that's looking for it. So if you just specify the file name, it'll assume they're in the same folder. If you specify the whole file name starting with http://blah, that's an absolute path. If you specify just the end of it, no, the end can be quite specific. If you specify just the end of it, that's a relative path. So that's relative. Also, you can specify folders even within a relative path. So in this case, we're saying the file I'm looking for, the folder I'm in now, go inside in the staff folder in that, and then looking for classes.html. So you'll see this in your other modules as well. Paths. You can have absolute paths and relative paths. You can even say go up 2 levels and then come down here and down here and down here. It can be quite specific. I would recommend that you put all of your files in the same folder for now, just to make your life simpler. However, there's a widely used practice where people put all the photos in a separate folder called photos, just to put them out of the way, so they don't clutter up the folder. So you can see your HTML files. Then you might have 10 HTML files and a folder for photos, and all the photos are in there. In which case then you'd be using a path that specifies, /photos/birthdayparty.jpg or something. So you can do that too. But it does make your life slightly more complicated, but not much. But you don't want them all over the shop. This here is saying go up a folder, then up a folder, and then down into staff, and classes.html is what you want there. So you can be quite complex and quite specific with these relative paths. You can put comments in HTML. When your page starts to get very complex, comments will be handy. You can break up the different sections and display what you want where. We'll look at this some more later. This is an important point. We'll look at that some more later. You can have a link here as well to email. So you can have mail2.colin.manning@CIT. And then if you click on that link, it'll crank up whatever email program the browser has been told to work with. Here in CIT in the labs, that's probably nothing at all. But on your home machine, or on your phone, or on your iPad, it would crank up your email straight away. So that can be very handy. We'll talk at length about images, so don't worry about that. But image tags must have the alt and the width and the height attributes in order to be correct. If you don't put those in, it'll still look okay. Probably it'll be fine. And this raises an important point. I hear lots, oh, but sure, the browser was okay with it, so it was okay. But you can write HTML that's incorrect, and the browser will still give it a lash and still have a go at displaying it. But that's not good enough. You need to write, syntactically perfect HTML. So just because the browser is happy with it and it looks okay, just because the page looks okay, that's not enough. It could still be wrong. You could still get 0 for it in an exam. You could still lose loads of marks for it. So it's important that it's correct. That's why some people prefer different browsers. Some browsers are very strict. Some browsers will have a tizzy fit and tell you, fuck off, I'm not doing it. Others will be, sure, 'tis grand. You obviously want the fussy one that's going to give out to you, because you want to get the HTML right. In the labs this week, we'll look at, strong and emphasis, and we will also hopefully look at lists if we get time today. I'm not sure how am I doing for time? Forgot to bring my watch. Now, because ASCII doesn't do special characters, we have some issues, okay? ASCII is American Standard Code for Information Interchange. So this was a code that had all of the letters of the English alphabet and some numbers and some things like that. It's very Anglo-centric. It never dawned on them that there were people in other parts of the world that would like to put accents or fathers over their E's, things like that.
Have they upgraded that and refer to UTF-8 as the superseded it? Would that be correct?
Yes and no. Yes and no. So, so if you want to do the ñ, as it's known in Spanish, or n tilde as we might call it, you really should do ampersand NTILDE semicolon. So that would give you the N with the squiggle over it. If you wanted to do an E fada, as we'd call it, or an acute E, you'd say ampersand E acute E semicolon. Of course, it also raises the problem, okay, if you want to do an ampersand, then how do you do an ampersand? Because, of course, if you do an ampersand, it'll look like you're trying to start one of these things. So if you want an actual ampersand, you have to do ampersand, AMP, semicolon. And if you're a maths lecturer writing a HTML file, it must be brutal because all your less than and greater than signs, of course, start to look like the beginnings of tags. So if you want to do a less than, you do ampersand LT, semicolon. There are also numbers associated with special characters, and you can just specify them by their number as well. So you can say ampersand hash 241 semicolon, and that's another way to get the ñ, for example. So you wouldn't be expected to know all these off the top of your head. You would be expected, I guess, to know the acute, at least, so that you can do fadas. Because Irish is, after all, the official language of the country, so I suppose you should be able to do that at least. If you're Polish, obviously you would want to look up the Polish ones. If you're Spanish, obviously you'd want to look up a few of the Spanish ones. You should at least be able to write your own name. If there's a father in your name, you should be able to write your own name properly in HTML. So if you just do E fada or ñ in, say, Notepad, and then you go save it, there's a good chance it won't save properly, but if it does save properly, there's a good chance that when a browser looks at it, it'll be screwed up. You sometimes see that if someone sends you a text message from Spain or from France, sometimes you see things get screwed up a bit if they use the accents. Okay? So you need to know of these, and you need to know at least E acute. Again, like Strasse in German, the sharp S in German, that's another one. So all these strange characters have their own things. Some of them have names. Some of them you just have to do the number. A lot of the Polish ones, you don't get the name with them. You just get the number. Okay. There's a website you can use to check your HTML. It's validator.w3.org, and it will tell you, you can like upload your HTML file, and it'll parse it for you and tell you, oh, you've a mistake somewhere here. This is allowed, this isn't allowed. So the stuff you do for your assignments should all be put through the validator, and then it'll say, yep, this is great, everything is fine. So if your page doesn't validate, there's something wrong. Now, there are one or two things you need to do, which we haven't discussed yet, to make it validate. There are different kinds of HTML. There are different flavors. And so you need to specify the flavor of HTML that you're doing first in order for it to work properly. But we can show you how to do that. That's just the thing you can copy and paste in when it comes to doing that. Okay? Oh, great. We've loads of time. Loads of time. So, in the labs this week, we're going to look at headings and strong and emphasis. So I'm not going to do those now. What I am going to do now is lists. Lists. Okay? Lists aren't actually that important. Okay, there's times on a website, on a web page, that you'd want to do a few lists, but they're not really a big deal. The reason we're going to spend time on them, though, is that if you get how lists work, then you get HTML. Okay? And that's why we're going to do the doggone lists for a bit. So you can have an ordered list in HTML. And that's OL for ordered list. So in the HTML, we'd say OL to begin an ordered list, and then /OL at the very end to end the ordered list. And then each of the elements inside, I like to think LI stands for list item. I don't know if it does or not. I just made that up in my own mind, but I'm sure, it's as good a thing as any. So LI, list item. So each item has a beginning and then an end. So we say OL to start the ordered list, then LI to start a list item, and we say New York, and then /LI to end the list item. And then we have LI to begin a list item, London, and /LI to end the list item. And then the next one, LI, Paris, and then /LI to end that. And then LI, Munich, and then /LI to end the list item. And then /OL to end the ordered list. Now you notice that all of the content in this list is inside in the list items. Every tag that's opened is closed. So we have an OL, we have a /OL. For every LI, there's a /LI. And there's nothing between the list items. Like you begin a list item, you begin LI for New York, and then /LI. There's nothing sitting between New York and London. There's nothing in that gap there. And that's very important. So this is the structure of a list.
And an ordered list always gives numbers.
Yes. So this is an ordered list, and it puts them then in order 1, 2, 3, 4. Or it might be A, B, C, D. Or it might be, I, IV, Roman, whatever. If you're looking at in a Japanese browser, it might put the numbers in Japanese or Arabic, whatever. But it puts them in an order. Okay? You'll notice that we haven't said in the HTML 1 New York, and 2 London, and 3 Paris. We just say here's an ordered list, and here's the list of the things in the list, and it's the browser that puts the numbers in. And we let the browser do its thing. There's something I'm going to say an awful lot in this module, but you specify the structure of the HTML, and then you let the browser do whatever it does. So if you think, oh, but I'd like New York in bold, no. Or I'd like Paris in green, no. Okay? It's an ordered list. You specify an ordered list, and away you go. And then the browser does whatever it does. We'll see later in the module, if you do really want all those things in green, there's a way to do that. It doesn't go in the HTML. An unordered list is very similar, except that there's no numbers or letters. There's just bullet points or whatever. I mean, they could be bullet points, they could be dashes, they could be stars, they could be happy faces, whatever. Freaky hippie browser wants to use happy faces, fine. Again, you only worry about the structure of the HTML, and in this case it's exactly the same, except you have UL for unordered list. And again, every tag that's opened is closed. A definition list can be handy. It was kind of designed for manuals, computer manuals, code manuals, where you might have, a term in a computer language, and then it would explain all that and stuff. What's handy though is that it can be used, it's handy for things like menus in a restaurant, stuff like that too. Okay? So a definition list has a beginning and an end. But then inside in that there are two kinds of elements. There's a DT and a DD. I like to call them in my own mind definition term and definition for want of something better. I'm sure there's a real term somewhere, someone can look it up. Okay? And so if you look here, we start the list and then we have the term. So in this case we have espresso, and then we have DD, which is the definition of that. So you can see how it looks a bit like a dictionary. Now again, we've just specified the HTML here for how to do this. The browser does whatever it does. So the browser, I guess, has decided that the term, the DT part, that goes in italics, and that the DD part is in regular text. The browser might have decided that the DT goes in bold and the others in regular, whatever. That's something the browser does. The browser does what it does. We just specify the HTML, the thing that we want. We specify the structure that we're looking for. You don't use definition lists that much. I think the place they're ideal though is on a menu. If you're explaining, this is, this kind of chicken curry, whatever. It's, got this and this and this and this. No. Any questions on any of that? So I'm going to let that sink in, and perhaps in the labs I might give you an exercise to do, but I won't give you that now. I'll just bring it with me on the day. So I'll put links to these slides on the blog somewhere. No. Blackboard hates me. So I'll probably just put a link to these on the blog. That's colinmcit.blogspot.com.
Are you putting all your lectures and labs on the blog?
That's probably what I'll do, yeah. Any other questions? I'll try and get back to those people who want to do the moves. I'll try and get back to them. I just need to first maybe establish the numbers in each group. If there's someone who is assigned a group and I haven't seen them in a while, I just need to track down and see if they're actually here or not, and then we'll see how we go. Okay? Great stuff. Thank you.